Okay, today we're going to be talking about solving equations by taking square roots. So it'll be module 22.1. Let's get started. All right, so remember this is the radical symbol. This is a square root here. And when we're looking for a square root, what we're looking for is we're looking for a number that when multiplied by itself would give us the number inside of the radical symbol. Okay, what do I mean by that? Well, if we're taking the square root of 25, we're looking for a number that when we multiply it by itself would give us 25. So the square root of 25 would be 5 because 5 squared equals 25. Okay, that doesn't equal each other, but the reason why the square root of 25 is 5 is because 5 squared is 25. But especially for this section, we need to think of any other integers that might give us 25 when we multiply it by itself. And specifically, I want you to think of negative integers. So we know that 5 squared is 25. And that's why the square root of 25 is 5. But there is another answer, because there's another number that when we square it would give us 25. And I want you to think of a negative number that when you square it would give you 25. Pause the video and think about that. That number would be negative 5. Negative 5 times negative 5 is also positive 25. So when we take the square root of 25, there's actually two answers. It's plus or minus 5. We could have a positive 5 or a negative 5 when we're taking square roots. And that's especially important with this module and when we are solving quadratic equations by taking square roots. So if we wanted to take the square root of 36, it would not only be 6, but there's another number, there's another integer that when we square it would give us 36. It would be both positive and negative 6, because negative 6 squared would give us 36, and 6 squared would give us 36. Okay? And you always need to include that. It's both positive and negative. All right. Now, something else I wanted to show you with square roots is simplifying square roots. And for that, I want to briefly talk about the product property of radicals. And this is the product property of radicals. If you have the square root of a number, you can split it up and turn it into a product. And this is especially important when we don't have a square root that gives us an integer as an answer. For example, let's go ahead and do 8, right? Square root of 8. Well, there is no integer that would multiply by itself and give us 8. Okay? In fact, if you put square root of 8 in your calculator, it'll give you a decimal. But you can split this up to something that does have a square, something that does have a square root is what I meant to say. Something that would have an integer as a square root. We could split this up to the square root of 4. Actually, let me do it this way. Right? This is the same thing as saying the square root of 4 times 2, right? 4 times 2 is 8. And we could split that up as the square root of 4 times the square root of 2. Now, why would we do that? Well, we still can't do anything with the square root of 2. That's not going to give us an integer as an answer. But square root of 4 would give us a 2. And remember, it would be plus or minus 2 because it could give us a positive or negative 2. And then that is how we would simplify radicals. We would change the radical. We would change the number inside of the radical symbol into two numbers, one of which does have an integer solution as a square root. Okay, let's do another example. Let's do the square root of 50. Okay, now the square root of 50 would be a decimal, but we can go ahead and change this to 25 times 2. Now, why would I want to do that? Well, because although I can't take the square root of 25, I can take the square root of, although I can't take the square root of 2, I can take the square root of 25. So this answer would be, well, the square root of 25 is plus or minus 5 times the square root of 2. That's how you would simplify radicals. Now, something else that I want to tell you about square roots is the quotient property. So that's if you have a fraction and you're taking the square root of a fraction, you can break it up with it being the square root of the numerator divided by the square root of the denominator. So for example, if you have the square root of 25 over 36, you could break that up into the square root of 25 over the square root of 36, which would be square root of 25 over the square root of 36. That would be plus or minus 5 over 6, plus or minus 5/6. That would be your final answer. All right, and another thing I want to briefly mention before we move on to our actual lesson, while we're in this little square root section, is that we never want to have a radical symbol in our denominator. We never want to have a square root in our denominator position. Okay, it would not be considered simplified, or it would not be considered simplified if we have a square root on the denominator position. So, for example, if this was 5 divided by the square root of 7, we don't want that square root of 7 on the bottom there. We would want it to take it out. Okay. Now, the way you would do that is you would multiply the numerator and the denominator by the square root of 7, or whatever number you're trying to get rid of. What would that do? Well, the numerator would just be 5 times the square root of 7, right? Well, but the denominator, and recall the product rule here, it works backwards as well. So if we have a square root of 7 times the square root of 7, we could actually just put that in there as the square root of 7 times 7, which would turn that into the square root of 49. And that would get rid of the radical symbol. Oops, I forgot the 5. And it would just have our denominator as 7. Okay, that's another thing I want you to briefly jot down in your notes. You don't want to have a square root symbol in the denominator position. Okay, so quadratic equations of the form ax squared plus c equals 0 can be solved using square roots. And that's the main part of our lesson today. That square root section on the last slide was just a little review. But this is what we're doing today. We're solving quadratic equations by taking square roots. We've already solved quadratic equations by factoring. Today we're going to solve them by taking square roots. Let's do it. So here are the steps. So if they are in that form, ax squared plus c equals c, you want to first isolate x squared and take the square root of both sides. That's how you would solve a quadratic equation by taking square roots. So go ahead and pause it and write this down. We're going to do a couple examples. All right, so here we have 5x squared minus 21 equals 39. So your first step is going to be to isolate x squared. All right, and get x squared by itself. Solve for x squared. So the way you would do that is you would first add 21 on both sides. All right. Solve this equation like you would any other equation. And that would give you 5x squared equals 60. Okay? Then your next step is going to be to divide both sides by 5. And if you divide both sides by 5, you get x squared equals 12. Now, here is where we would actually solve this quadratic equation. How would we get rid of this square? Well, the opposite of squaring something would be taking the square root of something. But whatever you do on one side, you have to do on the other side. So the square root and the square will cancel out. And we'd be left with x equals the square root of 12. Now, here's where simplifying radicals comes in. So you can't take the square root of 12 and get an integer as an answer. You're going to get a decimal. But you can split 12 up into the square root of 4 times 3. Why would you want to do that? Well, because you can take the square root of 4, even though you can't take the square root of 3, or at least not take the square root of 3 and get an integer as an answer. All right, so what's your answer going to be? Remember, you have to include both the positive and negative version of the integer. That would be plus or minus 2 times the square root of 3, and that's how you would leave your answer. Those are your two answers. And normally, remember from when we solved these with factoring, normally you're going to get two answers when you're solving these type of quadratic equations. And we have two answers here. One of our answers is positive 2 square root of 3, and the other answer is negative 2 square root of 3. Or you could just leave it as plus or minus 2 times the square root of 3. All right, here's another one. So first you would isolate the x squared. So you'd want to add 21 on both sides. And that would leave you with 6x squared equals 54. Okay? Then you would divide both sides by 6, and you'd get x squared equals 9. And this one's actually going to be quite nice because you can take the square root of 9, right, and get an integer as an answer. So to get rid of that square, you want to take the square root of both sides. Now, that'll cancel that out, so it's just going to be x equals Now the square root of 9 is 3, but remember, it could also be negative 3 because negative 3 times negative 3 is also 9. So your two answers will be 3 and negative 3, or plus or minus 3. I want to include one thing here that I want you to put in your notes. Let's say we had x squared equals negative, let's just say 25. All right. Now, you might say, well, you're going to take the square root of both sides, and yeah, that's normally what you would do. You take the square root of both sides, and that will leave you with x equals the square root of negative 25. Now, if you go ahead and put this in your calculator, you'll see this is not going to give you a real number as an answer. Why? Well, can you ever square a number and end up with a negative? No. No, because when you're squaring a number, you're multiplying it by itself 2 times, right? So negative 3 squared, a negative number squared, is always going to be a positive because a negative times a negative is a positive. And a positive number squared is always going to be a positive because a positive times a positive is going to be a positive. So if you get something like this, that means that your quadratic equation is going to have no solution, or it's not going to intersect the x-axis at any point. Okay, so if you get an answer like this, this would be no solution. And I want you to add that to your notes because I did forget to include an example where you would have no solution. If you end up with a negative number, you can't take the square root of a negative number and end up with a real number. You'd have no solution. One more thing that I want to talk to you about in this video, what about if we have a quadratic equation in this form? So if it's in this form, what you would do is you would isolate this part of the quadratic equation and then take the square root of both sides. So go ahead and pause the video and write this stuff down, and we'll do an example. All right, so here we have it. You're first going to want to isolate this part of your quadratic equation. So to do that, you are going to divide both sides by 5. And if you do that, you get x minus 9 squared equals 3. All right? And then you would take the square root of both sides. Now, taking the square root would cancel the square, which is perfect. That's what we want. And that's going to be x minus 9 equals the square root of 3. Or plus or minus the square root of 3. Because remember, it could be positive or negative. Now, over here, what you would do next is you would add 9 on both sides. And you can't actually do 9, well, you can't do anything with that. So it would be x equals 9 plus or minus the square root of 3. And that would be your final answer. So if we break this up, that could be 9 plus the square root of 3 or 9 minus the square root of 3. Those are your two answers. All right, so here we have 3 times x plus 1 squared equals 21. So this one's going to be a little nicer. We're first going to want to isolate this part. So we would divide by 3, and we are left with x plus 1 squared equals 9. Then you would take the square root of both sides, okay? And that cancels out those squares, so you're left with x plus 1 equals, well, the square root of 9 would be plus or minus 3, okay? What you're going to do next is you're going to subtract by 1 on both sides. Now here, you're going to have 2 possible cases here, and you're going to have to split it up, because this could either be 1 plus 3 or 1 minus 3. Those would be your two answers. If it's 1 plus 3, that means your answer would be 4. If it's 1 minus 3, that means your answer would be negative 2. So your two answers for this one would be 4 and negative 2. And we'll do a few more examples of this in class, get you ready for your test on Friday. If you have any questions, come to tutoring. Have a great night. See you tomorrow.